this lesson, we'll be factoring trinomials. At the end of the lesson, you should be able to solve equations in the form of ax squared plus bx plus c. So factor by grouping, remember, means the terms with common factors are grouped together, and then we change it to the form a times c plus d plus b times c plus d. So the c plus d has to be the same. And then we distribute to check and make sure. So if the coefficient of a is greater than 1, so we have ax squared plus bx plus c. So a is a number greater than 1. Then we have to use the MAC. So that means we multiply a and c. Then we find two numbers. When you add them together, equal the b. And when you multiply them, they equal the product of ac. And then again, we change it to the form ax squared plus bx plus c. So the two bx's go together to go back to the original. And then we factor by grouping. So steps for solving. So factor the trinomial. Make sure you look for the GCF first. It may make your problem a lot simpler. Then set each factor to 0 and solve. Usually has two solutions. Make sure you check them. So in this first example, 9p squared plus 6p minus 8 equals 0. First thing I want to do is multiply the a and c. So 8 times 9 is negative 72. So we're going to ask the question, what two numbers multiplied equal negative 72 and add together to equal 6? So you can see over on the side, I have already got all of the factors of negative 72. So the one that when I multiply them equal negative 72, when I add them equal 6, is negative 6 and 12. So I'm going to rewrite that equation. So it says 9p squared, and then minus 6p plus 12p, and then again back to the minus 8. So you can see that if I combine like terms, I would get back to my original equation of positive 6p. Now that I've got four terms, I'm going to factor by grouping. So I'll group together the 9p squared and the 6p, and the 12p and the 8. My GCF of the first group is 3p. So when I divide, I get 3p minus 2. And my GCF of the second group would be 4. So when I factor out the 4, I get 3p minus 2. So my two factors, my two binomials, are 3p plus 4 and 3p minus 2. I set both of those equal to 0. So then I subtract 4 and divide by 3 on the first one. And the second one I would add 2 and then divide by 3. So my solutions would be 2/3 and negative 4/3. All right, next one. 6q squared minus 13q equals negative 6. So the first thing I have to do is rewrite that equation so it equals 0. So I would add 6 to both sides. Then I multiply a and c, so 6 times 6 is 36. So what two numbers multiply together to equal 36 and add together equal negative 13? You can see from my chart that would be negative 4 and negative 9. And then to add them together will be negative 13. So I'll rewrite my equation. 6q squared minus 4q minus 9q. If you put those together, that's the 13q. Plus 6. So we spread them out so we get 4 factors. So if I got 4 factors, I factor by grouping. The GCF of the first set would be 2q. So that would get me 3q minus 2. And my GCF of the second group would be negative 3. If I divide by negative 3, I get 3q minus 2. So the two factors match. So I put them together and put 2q minus 3 and then 3q minus 2. I have my two factors. I set them equal to 0. 2q minus 3 equals 0. So I add 3 to both sides and then divide by 2. In the second group, I add 2 to both sides and divide by 3. So my solutions would be 3/2 and 2/3. 10w squared minus 19w equals 15. First thing I'm going to do is change it so that it equals 0. I'm multiplying a and c, so 10 times negative 15 would be negative 50. So I'm looking for two numbers When you multiply them, they equal negative 150, and when you add them, they equal negative 19. So that from my table is 6 and negative 25. So I'm going to rewrite the equation, put 10w squared plus 6w minus 25w minus 15 equals 0. Factor by grouping, so I'm going to put the first two terms together and the last two terms together. The GCF of the first two terms is 2w, so I factor that out and get a 5w plus 3. My GCF of the second two terms is negative 5, so when I factor that out, I get 5w plus 3. So I'm going to rewrite the two binomials as 2w minus 5 and 5w plus 3. Set those two to 0, so 5w minus 5 equals 0. I add 5 to both sides and divide by 2. And the other one, 5w plus 3 equals 0. Subtract 3 and then divide by 5. So the solutions are 5/2 and negative 3/5. All right, in this one, 6h squared plus 8h plus 2, notice that there is a GCF among all three terms. So that will be my first step, is to factor out that GCF. So then I get 2 times 3h squared plus 4h plus 1. Now I take my a and my c and multiply those together. So then I'm looking for what two numbers multiplied equal 3 and add together to equal 4. Rewrite the equation. Don't lose that 2 out in front. So I change the 4h to h and 3h. So I rewrite the equation 2 times 3h squared plus h plus 3h plus 1 equals 0. I've got 4 terms, so I factor by grouping, keeping that 2 out there. So I group it to 3h squared plus h and 3h plus 1. Find the GCF of those two. So the GCF of the first group is h. So if I factor out an h, I would get 3h plus 1. In the second group, my GCF is 1, so I'll go ahead and factor out a 1. So I'm going to rewrite it. So it's 2 times h plus 1 times 3h plus 1. Since the 2 does not have a variable, I don't need to set that to 0. So I just set the other two, h plus 1 equals 0 and 3h plus 1 equals 0. In the first one, I just subtract 1. And then the second one, I subtract 1 and divide by 3. So my solutions are negative 1 and negative 1/3. So how do you know if you need to find a solution? If it's an equation, if there's an equals 0, you know that you need to find a solution that will be in braces. What do you look for first thing? You look for that GCF.